All right, so today on day 4, we are going to discuss the broker responsibilities, what exactly broker is responsible for. So, till now, we have seen what is broker, what is cluster, offset. Offset we have not seen. We will discuss it today. Partition, topic, and then we discussed what is the segment.
Mhm.
Then yesterday we mainly discussed about the zookeeper because zookeeper
Yeah.
is kind of a management entity, and zookeeper is a different process which will be running on the machine. So we know that to set up the Kafka cluster, we have to run some processes on the system.
Mhm.
For example, when we do the lab session, you have to get ready with your laptop with good memory. RAM should be enough so that we can run multiple brokers. So one broker means one process, two broker means two process. Okay. So we have to run processes for each and every broker.
Okay.
Similarly, for Zookeeper also we have to run a separate process. Okay. So
Okay.
in the real world scenario, what happens is one machine, they will run only one broker process, and that machine will become your broker. Similarly, for second machine, on that second machine also we will run this, and that entire machine will be called as broker. Okay, but for our purpose, because we cannot have more than one machine, correct? We have only one laptop, so we will set up all the broker on the same machine only,
Mm.
right? So suppose I want to set up a three broker cluster, then I have to run three broker processes on the same laptop.
Mm.
And obviously, Zookeeper is very much required because without Zookeeper, there will not be any cluster formation. There will not be any connectivity between brokers. So
Mm.
Zookeeper also we have to run separately. So for three broker cluster, will have to run three broker processes and plus one. One means Zookeeper process. So total four processes we will have to run on our
Okay.
laptop. But if you want to run only one broker cluster, then one process for broker and one process for your zookeeper. That will
Okay.
be enough.
Mm.
Okay. So let's discuss about the broker responsibilities. So first one is messages of the topic spread across partitions. Okay. So that is the first thing. We know that partitions are nothing but they are the part of the topic. So topic will be divided into multiple partitions,
Yeah.
and those partition will be distributed across multiple brokers. So that we know. But
Mm.
when the message comes from producer, it will go to which broker, that is decided by the uh, that is the responsibility of broker only. Decided by the uh, that is the responsibility of broker only. Okay,
Mm.
because generally what happens is whenever a producer sends a message to your Kafka cluster, it will send the message to any partition. Okay, and that thing
Mm.
happen in round robin fashion. Okay, so
Partition,
suppose there are
which has
hmm?
partition which has leader, only you can read and write, right?
Correct. So, but suppose there are three partition, then there will be three leaders also. Correct.
Mm.
Three leaders plus replicas will also be there.
Mm.
Correct.
Okay.
Right. So total, it depends how many party leaders will also be there. Three partitions mean three leader definitely will be there.
Mm.
Okay. So what I'm saying, obviously messages will go to leaders only, but that those messages will go in the round robin fashion.
Mm.
So you know round robin. What is round robin? So suppose I need to distribute something among
Would.
three brokers, then first message I'll send it to partition 1, second I will send to partition 2, third I will send to partition 3, and fourth will again I'll send it to partition 1,
One.
and then fifth one partition 2, sixth one partition 3, and again seventh will go to partition 1. So this process is called round robin,
Yeah.
distributing the messages equally to all the partitions. Okay, so whenever a producer sends message to the Kafka cluster into a topic, the messages by default will be sent in the round robin fashion to the partitions. Correct.
Mm.
Now that is the first thing. Second thing is, suppose I want to send my messages only to a particular partition. Is it possible? That is the question. So the answer is yes, that is also possible. If you want to send all your messages to only a particular partition,
Mm-hmm.
then you need to uh, decide a key for your message. So I think day before yesterday, I told you that whenever we send any message to Kafka, it will be in the form of key value pair, right?
Yeah. Yes. Yes. Mm.
So key is optional actually. It is not mandatory to send the key also. If you don't have any key or if you don't want to create any key for the message, you leave it blank. You directly send value only and send it. Key can be null also.
Okay.
So in that case, if key is null, then your message will be distributed in round robin fashion. But if you are assigning a key to your message, then key will always remain, you can say same. You make a common key and then send it. So because key is same, every time your message will go to the same partition. Okay. So what actually happens is when you send a key also, so key is converted into partition number. So what will do, Kafka will do? Hash number using that key. It will create a hash value of that key, and from that hash value, it will identify which partition number your message can be sent. Okay.
Okay.
So what I'm trying to say is, I'm writing here.
Mm.
You have a key. Suppose your messages are going with this name. Test message. Suppose this is the key you have given to your message. Okay.
Mm-hmm.
This is your key. And value could be anything, right? Or suppose here key I am giving car model. Suppose this is my key, and in the value I can give any car model. For example, I can say Toyota
Okay.
Creta. Okay, so this will be my first model, first car model. So key will always remain same car model, and this is value. So this is my first message. Okay. Second message. This is my first message. Second message again I will send. So for this key will be same car model, because actually we are sending car model only, and here I can give anything like Tata Harrier. Okay,
Mm-hmm.
this is my, and so on. So you know that key is same in both the messages. So this message, these two messages will go to a particular topic only. It will never be assigned to any other topic. Okay, but which topic it will go? Topic one, sorry, but which partition it will go? Partition 1, partition 2, partition 3, that will be calculated on the hash value of this key. Okay, so suppose calculation happened and hash value is coming as 0. Then this message will go to partition number 1. If hash value is coming as 1, okay, because generally partition numbering happens from 0. Because generally partition numbering happens from 0. If there are 3 partition, then first partition will be partition 0, second partition will be partition 1, third partition will be partition 2.
Okay.
So suppose hash calculation happened and we got the number as 2. Obviously, your data will go to partition number 2. Sorry, 3. So I hope it is clear, this concept. Messages can be sent to the Kafka cluster and they will be assigned either in the round robin fashion to a partition, or if we are sending key also, on the basis of the key, the messages will always go to a partition. Hash value is nothing but like what happens is when you calculate the memory of this memory location of this string. So we know that everything is stored in the computer memory with a location, and that location has some hash value. So we calculate the hash value like that.
Okay.
And then from hash value, we will convert, because hash value will be very big. It will be something like this much big number.
Okay.
Now what we will do is we will divide this number and get the remainder. Okay. After dividing that number, and we will get the remainder. So remainder will be only 1 digit, single digit.
Okay.
So that is how we calculate it. Okay, but we don't have to really worry about what is which partition it is going. Just make sure that if you are giving a key, then it will always be going to a single partition, because partition is decided that this will be the partition number for the key.
Yeah.
But suppose if you leave it blank, you are not giving any key. If key is null, for example, null means you are not passing anything.
Yeah.
If key is null, then your messages will go into round robin fashion. So
Round robin.
First message will be to first partition, second to second, third one to third topic, and again fourth one will go to partition 1. So is this clear?
Yes. Yeah.
So now my question is, what is the benefit of sending all your messages to your single partition? Can you tell me? If you have any idea, or if you can guess, otherwise I'll tell you. Of sending all the messages to the same topic. Sorry, same partition. Okay. First question becomes, how will you send all the messages from a sender to the same partition? So this answer I have given above.
Yeah. This one clear.
Yeah. By setting a key in the message. Now, second question is this. So the answer of this question is why we need to send all the messages to the same partition. If your producer sends a message, or I can say a data, which must be processed in order, then ordered by the consumer, then we have to send it to same partition. Okay, this is the answer. So we know that if I'm sending a data to Kafka, my data will go to any partition if I'm not setting any key, correct? Now those partitions will be read by different consumers, correct? Suppose there are 3 consumers on the right hand side, and one consumer can read only one partition. Okay, that I think initially only I told one consumer, but I'll explain these things also again. But for the time being, you can remember this thing. One consumer can read only from one partition. Okay, can read only from one partition. Okay, two consumer cannot read same partition simultaneously. It's not possible. Okay, so suppose one I'm sending some data. Okay, that data is for example need the processing in the sequence. Okay. Then if my first part of my data is consumed by consumer 1, and second data goes to consumer 2, like second data goes to partition 2, then obviously it will be read by some other consumer. Okay, so same consumer cannot process my data in a proper sequence. That is the reason. I'm repeating again. Suppose you are sending a data of data. So for that, what you want is consumer 1 only should process my entire data. It should not be divided into 2 consumers. So what you will do, you will send all my data to a single partition. So the consumer which will be reading that partition will read the data in the proper sequence. One by one. So that is the reason, that is the benefit of sending all your messages to the same partition.
Okay, got it.
Okay. Now let's get started with this broker responsibilities. So first point we have covered, messages of topics spread across partitions. Okay. So broker will hold the partition, this we know. Okay. Whenever messages of topics spread across partitions. Okay. So broker will hold the partition, this we know. Okay. Whenever we send a message, obviously partition will be distributed across brokers. So that's how the data is stored. And partition spread across brokers, this also we covered. Each broker handles many partitions, this also we have covered already, right? A particular broker can have one leader and replicas of some other partition. Okay. Similarly, it can have 2 leaders plus few replicas of some other partitions. So obviously, broker can handle multiple partitions. Each partition is stored on broker's disk. So I think this also I've told many times that partition is. So whenever you are sending any data, it goes into partition. Ultimately, it goes into a file. Because partition is just a logical concept. Ultimately, data will be stored in on the disk inside a file. Right?
Yeah.
And next point is partition. Partition is nothing but 1 to n log files. So I told just now. Partitioning is nothing but there will be multiple files which will be attached to that partition. So whenever we write any data to partition, that will go to those files, nothing else. Each message in log identified by offset. This I'll explain in the next slide what is offset. But as of now, you just remember this word, this line. Each message in the log identified by offset. So we know that data is written into a log file. Okay. Yesterday I showed you one diagram where I showed that this is our partition, and inside that partition we will have segments.
Segments.
And, those segments are nothing but the files. One segment is one file, another segment is another file. So what happens is, suppose data is going to be stored on the in a file. Obviously, we cannot keep writing data on the same file. So generally, you know how log file works. For one day, one log file. Second day, another log file is created. Third day, log file is again rotated and a new file is created. So the same way, in partition also there will be a new file is created. So the same way, in partition also there will be multiple files, and data will go to those files only.
Okay.
So that's why partition is nothing but 1 to n log files. Each message in log identified by offset, and obviously whenever a message is written, there will be a number assigned to that message that is called offset. We'll discuss it further. And obviously the retention policy will also be configured in the broker. If I have configured retention policy as 30, then it will be retained, data will be retained for 1 month. If I have not configured anything, then by default 7 days. So these are the responsibilities of brokers. Any doubt?
No.
We are going ahead now. Now, again, this is very simple thing which you can see. Producer, consumer, and broker. Broker is having partition. I'm just repeating these things again and again, but there is no harm if we read something which is already discussed. That will just make our fundamentals more stronger. So producer sends a message to broker, yes. Broker receives and stores the message, yes. This we also know. A Kafka cluster can have many brokers, yes. That is also correct. Each broker manages multiple partitions. So I think there is no doubt in these 4 points.
Yes.
Now let's talk about replication. So a replication is required because we need fault tolerance. If replication is not there, tolerance. If replication is not there, for example, just assume if there is no replication, then in case of any failure, you will not be able to recover your data. Your data is gone. So that's why we create the copy of the data to achieve this fault tolerance. 1 lead partition and n-1 followers. This also we know already. Suppose there are 3 partitions, then how many leader will be there? 1 leader.
3 leaders.
Okay.
3 leaders.
Yeah. N leader will be there, correct. But if I'm saying for single partition, how many leaders will be there? 1 leader.
1 leader, yeah.
Okay. And replica will be how many replica you want to create? Okay. I think there is a doubt. I'm repeating again. Suppose you want to do the replication for any partition. So suppose you have decided I will create 3 replica for each partition. Okay. So suppose there are 3 partition in your topic. How many replicas will be there?
9.
9, correct? 9 will be there because when I'm saying I will create 3 replica, it will also include leader.
Yeah.
Including leader, there will be 3 replicas. So one will be leader
Leader
and
and
two
two
will be,
replica.
yeah. So that's why I'm
Okay.
saying n-1 follower. So
Okay.
those replicas are nothing but followers.
Okay.
Clear? General writes and reads happens to the leader. This also we know.
Mm-hmm.
An invisible process to most developers. So this process is very much invisible to developers. Only theoretical we know that read and write happening from the leader, but when you read the data, you will not be able to see that the data is coming from leader or replica.
Okay.
So this
The
is,
background process.
yeah, this thing happens automatically. Okay. Now, in replication, what is leader? I know, correct? Uh, what is follower? That also I know, correct? So
Yeah.
these terms, and now replication factor is something we don't know. So it's also very simple. Replication factors indicates how many replicas of a partition exist. Replicas of a partition exist. Okay, including
Okay.
leader. So when I'm saying the replication factor of your topic, okay, replication factor of your topic is 3. It
Uh-huh.
means
One.
whatever number of partitions are there in your topic, 3 replicas will be created for each partition. If replication factor is 4, it means 4 replicas will be created for each partition. Okay. If replication factor is 9, then 9 replicas will be created for each partitions. So just a simple thing, replication factor, no confusion.
Replication means just for the fault tolerance we are having.
Replication factor, no confusion.
Replication means just for the fault tolerance we are having just a backup, right? So why we need to keep more than one replica, like one leader and one replica is enough. One follower is enough, right?
Yeah,
Why we
one.
need?
Yes, yes. I'll tell you why we need. That's a good question. Why we need. The reason is another machine can also fail, right? Why we need more than one replica, right? This is your question?
Yeah. Yes.
Okay, so the answer is, suppose I have created one leader and one replica for a partition, correct? Okay.
Okay.
Then which one become the leader?
The replica become the leader.
Replica will become the leader, correct?
Yeah.
Now, will there be any other replica left in my
No.
system? No. Only leader is there, replica is gone. Because replica is now become the leader, right? And until unless that old system which got crashed comes up again, we have to manage with that single leader only, right? There will not be
Yeah.
any replica. So isn't it, we can say it's a risky thing, right? Because if a system crashes, it will not come again immediately. It might take some time, okay? 2 hours, 3 hours. You need more replicas so that even if a new leader is elected, you have sufficient number of replicas in your system.
Okay.
So that is why whenever we say replication is required, replication factor of 3 is always suggested. More replicas are required because in case of failure, replica become leader and we are left with no replica, correct?
Uh,
are left with no replica, correct?
uh,
So it's always recommended to have at least one leader or at least one replica available in case of disaster. Okay.
okay.
So suppose, for example, if we have only two replicas means one leader and
One
one
follower, one leader, one
follower.
replica.
Yeah. So this is, will this give you the fault tolerance in case of disaster? No. Why?
No, yeah,
Because second machine can also fail. Right?
yeah.
First replica, the leader got failed. You made the follower as leader. Now this leader might again fail. It is a chance, right? If disaster can happen, that can happen to second machine also. So you will be left with no other replica. So this is risky. But suppose if you have created three, then it means one leader and two followers.
Follower, yeah.
So this is more reliable because what will happen? Suppose then in the end you will left with still one leader. So your job will be still continue even if there are two failures. So it is always recommended you keep replicas as much as possible, but also it should not be very high, it should not be very low. It should be kind of average thing. Like three is fine. If you want, you can make it five also or four also. But lesser than three is never recommended.
Oh, got it.
At least your system should have the capability that it can fail two times.
Yes, yes.
Okay, let's go ahead. So replication factor is clear to you? What is replication factor?
Yes, yes. Fault tolerance we are making, we are make sure that we have more than one follower so that one
Yes,
any system crashes, the first one become the leader and another become the backup.
correct. This is my question. If replication factor is 3, how many replicas will be created?
One leader and two followers.
Yeah. So you can say 3 replicas will be created. We consider everything as copy because all are having the same data. So
Yeah,
if
yeah.
in total replicas, then
Three.
obviously leader copy because all are having the same data. So
Yeah,
if
yeah.
in total replicas, then
Three.
obviously leader will also
Three.
be included. 3 replicas, which will have one leader and two followers. Let's go ahead now. So leader is clear, follower is clear, replication factor is clear. Now, this is my replication factor 3, and this is my cluster situation, cluster condition. So in this cluster, you can see the replication factor is implemented as 3. Now you tell me, is it correct or not, this diagram?
Sorry, your cluster is
Yeah.
what was
In
the
the
question?
bottom, you can see replication factor is 3. Okay.
Okay.
So, and you can see there are 3 partitions
Mhm.
of the topic. Topic has 3 partition. So those 3 partitions are shown in 3 different colors: green, orange, and blue.
Okay.
So can you tell me the replication factor 3 is implemented in this broker, in this cluster or not?
Yes.
Okay. How many brokers are there?
4 brokers,
4 brokers are there. How many partitions are there?
3 partitions.
3 partition for 3 partitions are there for we have this main leader partition 0,
Mhm.
and wherever you can see R2, R1,
Mhm.
these are the replicas.
Yeah.
So replicas in the sense we can say follower. So partition
Okay.
0, this is the leader. So leader is stored, or leader is with broker 101. Now
Mhm.
the replica of this partition 0, the first replica is on broker 104
Okay.
R1, and second replica is on broker 102. So
Yeah.
for partition 0, we have 3 replicas, 1, 2, 3. So this is correct. Partition 1 also we have 3 replicas, 1, 2, 3. Partition 2 also same thing, 1, 2, 3. So for all the partitions we have 3 copies. It means replication factor is 3.
Yeah.
The replication factor was 4, then there should have been 4 copies of each partition.
Mm.
Make sense?
Yes. Yes. Yeah.
Okay. This is the same thing, this particular diagram, just a different kind of view shown here. So suppose your topic is this circle. This circle is your topic. Okay, and these parts are nothing but the partition. So 0, 1, 2, 3. These are partition.
Mm.
Okay. Now for each partition, you have to achieve the replication factor of 3. So obviously we have here 5 brokers: 1, 2, 3, 4, 5. Now what will happen for this partition number 1? Okay, you partition number 1 means you can see this is the second partition of this topic. So for this particular partition, its replica is on broker 2. Its one more replica is here on broker 3, and third replica is there on broker 5. Okay, because the number is same, it means these are the replicas of your partition number
Okay.
1.
Mm.
Okay, nothing else. So whatever picture is more convenient to you, that you can keep in your mind, this one or this one.
Okay.
Just giving a different idea, so that sometimes what happens, people see a different kind of picture, they understand that
Understand.
yeah, differently they start assuming, like whatever
Mm.
I have learned that was wrong, not correct. It's not like that. So like whatever
Mm.
I have learned that was wrong, not correct. It's not like that. So the pictorial view can be different for the same scenario.
Okay.
Let's go ahead now. As I said, we will discuss now offset. What is offset actually? So offset is a sequence number given to a message whenever a message goes to a partition. So suppose this bigger box, it is my partition, this entire box.
Uh-huh.
And we know that message goes to a partition whenever we send any message from the producer. So my message 1 came first, then I send message 2, then I send message 3, 4, 5, and so on. So my messages are coming in the form of first in, first out.
Mm.
Uh, they will come from this side, and they will be consumed from this side. Okay.
Yeah.
So obviously the first message which arrived in the partition, that will be given the number 0. Second message will be automatically given the number 1. Then third message 2, fourth message 3, fifth message 4. So these numbers which are given to the messages, that these numbers are called offsets.
Like unique ID numbers.
We are giving, sorry?
Like unique ID number.
Yeah, ID number unique, but not across the two different partition, because I'm talking about only single partition.
Single partition.
So within the single partition, it is unique. But if you talk about two partitions, then in the second partition also the numbering will happen from 0 only.
Yeah, same. In this partition, we have like data coming in, like the flow like M1, M2, M3. These are these are called as segments, right? These M1, M2, M3 is called segments, right?
No. I think you are confused. Segments are nothing but the files where these data will be stored. M1, M2, M3, M4, M5. These data will go to in a file. This will be written in a file. But each and every message which is written to a file, that will also be given a number. So that number is this offset.
Okay.
Let me remove that confusion. So your question was difference between partition. Your question was difference between partition, offset and segment, right? And offset. So the answer is segment is a log file where segment is a log file for the partition. This log file stores the data. Okay. Each data written into log file is given a number that is called offset. Okay, that is the basic difference.
Okay.
So segment can also be multiple, correct? For a partition, one file, then second file, then third file, because every day data is, you cannot put the data on the same file. You need a different file for second day. For third day, you need a different file. Like how this thing happen in case of log files, because you have worked already. So how the log files rotate.
Yeah.
Those log file become zip file after some time, right? In the same way, here also this thing happens internally.
Okay.
For one partition, there will be a segment file. In that segment file, you will start writing your messages. First message will be kind of, suppose this, I'm showing you just for better understanding. I'm opening a new tab. This is blank file, correct?
Yeah.
This blank file is nothing but my segment. Now, first message comes. Hi. How are you? This is my first message. So it will go at line number 1. So this is my offset. Okay.
Yeah. 0.
Yeah. Second thing is 2. Similarly, third message will come. That will be written here. Right. So you see this numbering are also coming. So these numberings are nothing but offsets. Okay. And this file is your segment file.
Segments. Yeah.
Okay, which represents nothing but the partition, because partition is a logical concept. Okay, but
Yeah.
where actually the data will be written, that will be written in a file, and that file is nothing but a segment. Okay, but here the numbering is starting from 1, but actually the numbering happens from 0.
0. Yeah.
That is the only difference. So I hope it is clear.
Yeah.
So what is from 0?
0. Yeah.
That is the only difference. So I hope it is clear.
Yeah.
So what is offset? If someone asks you, you can say that whenever messages are written to a partition, each message is given a unique number. That unique number is called offset. And the messages will always be appended to that partition. It's not possible that a latest message is coming and it is written in the first position. That is not possible. Okay.
Okay.
So offset is clear. We are going ahead.
Yes. Yeah.
Now, initially, when I explained what is the data is written in the form of key and value pair. Whenever we send the data will be in the form of key and value pair. But there are few more things which are also sent as part of that data. So one more thing is timestamp. Whenever you send any data to Kafka topic, you will also send the time also when you created that data. So that is nothing but the timestamp, date and time of the message creation. So generally producer will also add this timestamp. Okay. Then third one is compression type. Before sending the data, sometimes we compress also. Okay. So it's up to the producer whether you compress it or not. Suppose data is very big, it is always good if you can compress it if possible. If not, then that is also, but it is optional. There will be headers also. If you want to send some metadata, some more information about this message, then you can add headers also. But headers are also optional. And last thing is partition ID and offset ID. Okay, so these two things you will not send because you are the producer. These will be populated by the Kafka, partition number and offset ID. Okay, so wherever this data is going to be written, the partition number of that partition and offset ID that will automatically added here.
Okay.
Okay, so first 5 fields sender will send, last one will be automatically added here.
Okay.
Okay, so first 5 fields sender will send, last one will be added by the brokers or Kafka cluster. Okay, so that's all. I think one more thing. Oh, there are many things left. No problem, we can cover them up quickly. So till now, any doubt here?
No.
It is clear, no? Okay.
Yeah.
We have 4 minutes left. Okay, so suppose now I'm talking about reading the data from the Kafka topic. Okay. So obviously consumer will read the data. Now how to read the data? Because you should have some information, then only you can read the data.
Fetch the data. Yeah.
Yes. Suppose I tell you that you have to go and meet your friend. So obviously you need to know the address of your friend, wherever he stays, right? Then only you can meet him. So similarly, consumer, whenever consumer want to consume something, consumer has to know the exact location of the data, because topic name itself will not be sufficient. Topic name is, suppose topic name is car, but topic name is not sufficient to locate the exact place where the data is there. So apart from topic name, you should know the partition number also, so that you can reach to that partition. And inside that partition, there will be many messages. So you should know the offset also.
Offset number. Okay.
So to read any message, from the Kafka, you need three things: topic name, partition number, and offset. And we have discussed all these things in very much detail, right?
Yeah.
Topic is divided into partition, and each partition has the messages which are numbered, and those numbers are called offset.
Offset.
So if you have these three information, you can easily reach to that particular location and read the data. So whenever consumer will read the data, it will supply these three things to the zookeeper. Okay, and then zookeeper will provide the data.
Okay.
Now we are talking about the consumer group. I think this has to be discussed in detail. We'll cover this last topic tomorrow. Okay, because this has to be explained in detail. What is consumer group?
Okay.
So I'll switch to next PPT. I'll update it. So this PPT will contain slides still here only. Okay.
Okay.
These three slides I'll cover in day 5. All right. Any doubt till here? Jagdish, any question?
No, Sapam. Clear.
Okay. So I think after day 5, we will be starting the hands-on sessions. So I hope you have a laptop with enough memory so that we can run a small Kafka cluster in our laptop. Generally, for testing purpose, initially I need only one broker and one zookeeper. That's it. Okay.
Okay.
Then, as per the requirement, we will create more brokers in the cluster. But initially, we will start with one broker and one zookeeper. That's it. And then we will check how to send the data, how to receive the data.
Okay.
Okay. All right. I think then we are good. If you don't have any questions, whatever questions we have noted here, this I will upload in Google Drive. Just for sake of convenience, I'm adding all the recordings in Google Drive also. But please make sure to download them all. I'll not be keeping these recordings for more than 15 days in Google Drive because the size will keep on increasing.
Yeah, I understand. No, I'll download the videos and I'll be saving in my hard disk local.
Okay, that